Recording. All right. So good morning. So we've learned 5 visual elements in the last class. Let's remind what we learned last week. So we learned line, right, and shape and mass, and light, texture and pattern, and space. So did everyone post your discussion? Yeah. Do you know what was the answer? So I've posted the answer, the model room. Let's go to the discussion too. So for this painting, the Raphael's painting, he used 1-point linear perspective for this painting. Yeah. So yeah. So everything goes to the center like this. So there is a vanishing point on the center to compact lots of things in one frame. So he used this implied space technique like this. So 1 point, linear. I'm sorry, this is so bad. Let me just type it. 1 point. For the implied space. Please remember this. So this is the vanishing point on the center. All right. So, and I saw all of your artworks, the sketchbook project. You guys are awesome. So after the class, you can check my comments for your artwork.
I didn't know we were supposed to post them up, Professor.
Oh, the sketchbook project?
Yes.
Okay, so it was here. Go to week two of the model room, and then scroll down. Then you will see week 2. When you click the week 2, here, sketchbook 2.1. So
yeah, no, I put in what I was going to do.
did you post it?
No, I didn't actually upload the artwork. I have it. I can.
So today we are going to see 6th and 7th element, color and time and motion. So let's see the color first. So this is a prism to see the light with the color. So science tell us that we cannot perceive color without light. And light consists of energy that travels in waves, much as water forms wave. The distance between the peak of each wave of this energy is its wavelength, which is a term from physics that measures light. If white or normal daylight passes through a prism, we see that it is composed of constituent colors of light like this, which have different wavelength. So this is a color wheel. So we can divide colors as 3: primary color, secondary color, and tertiary color. So primary colors are yellow, red, blue. So these are labeled with number 1 on the color wheel. So they're called primary because they cannot be made by any mixture of other colors. And the secondary colors are orange, green, and violet. So these are labeled with the number 2. Each is made by combining 2 primary colors. So for example, here's number 1 yellow and number 1 blue. So these are all the primary colors. So when we mix these 2 colors, then we can make number 2, the secondary color, green. Okay. And the tertiary colors. So the tertiary colors are labeled number 3. There are lots of 3 between 1 and 2. So these are the product of a primary color and the secondary color. So for example, when you mix 1 primary color, yellow, and 1 secondary color, green, then you can make tertiary color, yellow, green. So now let's talk about color properties. So any color has 3 properties: hue, value, and saturation. So let's see what these are. So hue is the name of color. Hue is the name of color according to the categories of the color wheel, like red, orange, yellow, green, blue, like that. And value refers to relative lightness or darkness of the color, like this. And saturation or intensity refers to the relative purity of a color. So colors may be pure and saturated as they appear on the color wheel, or they may be dulled and softened to some degree. And there are 2 ways to see the colors by light and pigment. So it's additive color, and the other one is subtractive color. So let's see what these are. So additive color or RGB color, so which means R is red and G is green and blue B is blue. So it is a property of a color model that predicts the appearance of colors made by coincident components lights with distinct color. So RGB color uses for digital art, internet, TV, etc. And subtractive color or CMYK color. So C means cyan, the color name, and M means magenta. This pink color name is magenta. And Y is yellow, and K means black. So it calls CMYK color. So it is the kind of mixing you get if you illuminate colored filters with white light from behind, as illustrated as left. So CMYK color uses for all kinds of printing, like product printing, magazine or book printing, and all the paint color, like acrylic or oil painting colors, that is also using this CMYK color. So now we are going to see the optical effects of color. Good morning.
Good morning.
So there are two types of optical effects of color we are going to see. So first one is simultaneous contrast. And the next is optical color mixture. So let's see these colors effect. So let's see the simultaneous contrast first. So when there are two colors side by side, so these colors interact with one another and change our perception accordingly. So for example, complementary color. So now when you see the color wheel, there are opposite colors like yellow and violet and green and red, orange and blue. So these are called complementary color. So that is one of the popular example of the simultaneous contrast effect. So this is an example to use the complementary color to show the simultaneous optical color effects. So these are all the Vincent van Gogh's paintings. He used simultaneous contrast for optical effects of color in these two paintings. So let's look at the left painting first. So which color you can see in this painting?
The one on the left,
Mm-hmm.
the cool colors.
Yeah, the cool color, the blue color, yeah. And
Yellow?
yellow, yes, yellow and the orange, right? So yeah, orange on the the restaurant's terrace. So he used the dark blue on the sky and the yellow light with vivid orange outdoor dining spot. So the orange and the blue are complementary colors. So by using complementary colors as simultaneous contrast, the image is stamped on the viewer's eyes. And let's look at the right image. So which color the artist use?
Green color.
Green and orange.
Green and orange, perfect. Green and orange, gold, yeah. Very good. So the ceiling and all the tabletops are greenish color. And the rest of the parts are red and reddish brown color. So green and red are complementary colors each other. So this painting is also using the same effect of color, the simultaneous contrast. And the next optical effect of color we are going to see is it's a pointillism. So the colors can be mixed in light or pigment, but they can also be mixed by our eyes. When small patches of different colors are close together, the eye may blend them to produce a new color. So this is art movement, the pointillism, to use this optical color mixture effect. So let's see the example of the optical color mixture. So the left box consists of tiny red and blue dots. And the right box has red and yellow dots, right? And now let's look at these two boxes with your eyes half closed like this. Which color can you see in that box?
Purple.
Purple.
Orange.
That's right. Purple and orange. So that is optical color mixture by mixing colors in our eyes. So this is Georges Seurat's painting. So when you see his painting closer, you can see there are no brush strokes like other artist painting, right? And it consists of tons of tiny color dots. And all the colors in this painting are made by optical color mixture, which means the green color made by mixture of other colors, for example, like yellow and blue. And that technique is called pointillism. So Georges Seurat developed this technique in modern era, 19th century, as a post-impressionist. So these are all about color as visual elements in art. So there is a video about this painting, and in the Modern Room week 3.1, and you can see how he can create all the colors by using the optical color mixture effect.
What did you say pointillism was again?
Yeah, he's a pointillist. He used pointillism as a post-impressionist artist.
What is it?
Huh?
What was the definition of pointillism?
So pointillism means use the color dots to paint, not the brush strokes.
Okay.
Yes. So you can see the details in the about this painting in the video. So please watch the video after this meeting. I will show you where it is later. Okay, so now let's move on to the time and motion, the last visual element. So, so time and motion have always been linked to art. So during 20th century, time and motion truly took their places as elements of Western art. So through advances in science and technology, daily life became far more dynamic, and the nature of time and its relationship to space and the universe more a matter for thought. And there is implied motion like other visual elements. So we do not actually see the motion happening, but visual clues tell us that it is a key aspect of the work. So that is called implied motion. So let me show you the example to use implied motion in work of art. So like this. So this is a marble sculpture by Gian Lorenzo Bernini, who is a Baroque artist in 17th century. So as you can see, this is a sculpture. So there is no actual movement in this masterpiece, but the figures' poses are so dynamic and theatrical. So we could feel, oh, we are in the middle of the action. So that is implied motion. And here's another example to show the implied motion in the painting. Looks kind of, hilarious. So artist wants to capture all the moments of the motion in this painting. So artists can also, I'm sorry, this is a futurist artist. So Giacomo Bella. So he's a futurist artist, and the dynamism of a dog on a leash in 20th century. The artist tried to record all of time and motion of the certain moment in one frame. So we can see a dog and a person is walking from this painting. And that is implied motion. And let's see, illusion of motion. So artists can also communicate the idea of motion by creating an illusion of it. So artists create this illusion through visual tricks that deceive our eyes into believing there is motion as time passes, and even though no actual motion occurs. So let's see the example to use illusion of motion. So so there is a noticeable sense of movement when we look at this, cataract 3. So this painting is made by the British artist Bridget Lilly. So when you focus on the a single point in the center of the work, it appears there is an all vibrating motion. So this optical illusion grows out the natural psychological movement of the human eye. And the art that moves is called kinetic art. So from the Greek word kinetos means moving. So kinetic art is art from any medium that contains movement perceivable by the viewer and dependence on motion for its effect. So all kind of movable art pieces called kinetic art. So like this. So so this sculpture is moving, actually physically moving. So please, there is a video to show, about the kinetic art, this video in the Moodle room. So let me show you where it is. So please go to week 3. Yeah, week 3. And this blue icon. This blue page icon, please click this, week 3.1, the visual elements 2. And I'm gonna upload this recorded video here in this page. And then when you scroll down in this page, then you will see 2 links. One is for the, to show the pointillism, Georges Seurat's painting, and the other one is kinetic art. So please watch these 2 videos right after this meeting. And today we have a discussion. So please go to discussion 3.1. So this is the today's topic. So how is color interpreted in different cultures? Do colors affect our behavior? And what are some of the scientific aspects of color? So search for your favorite color and give us a short summary of the psychological aspect of your favorite color. Okay, so this is the topic for the discussion, and please reply to this discussion topic by tonight, and by tomorrow please reply to your peers, at least 2 or more. And